So the sky this month, April 9 to May 14. So a couple of highlights. First of all, Mercury and Venus are about to reappear. They've gone behind this or too close to the sun, but now they're going to be visible. There's going to be, the moon is going to journey past Venus, Mercury, and on to Mars. And so we'll take a look at that. And then that sort of prompted a thought in my mind about the daily versus the yearly motion of the sun, and for that matter, the daily versus the monthly motion of the moon. And one of our executive was sort of saying that it's really hard to kind of orient yourself to the sky, especially when you're thinking in terms of polar alignment. And so I was hoping that maybe by taking a look at this, we might get a better understanding of how to kind of switch between our ordinary kind of, angle on the horizon and then angle upward to thinking more in terms of a polar aligned type of thinking. So let's take a look. First of all, April 30th. So that's a ways yet. The sky is going to look something like this. And this is Mercury and Venus. And that's an indication of what 10 degrees above the horizon looks like. So basically, these two planets are going to appear on 9:30, April 30th, very, very low in the somewhat north of west sky. So if we can get down to Davis Bay Beach or somewhere where you've got a good western exposure, then western horizon, then maybe you'll be able to take a look and see Mercury and Venus. So that's April 30th. And then May the 3rd, again, very similar scene, but we've got Mercury, we've got Venus, but now we've got the Pleiades. And the Pleiades, of course, is easy enough to see in the middle of the sky in the pitch dark, but this is going to be just after sunset, and it's 20 after 9. And we're looking at, you probably need a pair of binoculars to be able to actually see the Pleiades, but Mercury right next to the Pleiades, I think might be quite an interesting sight. And you'll be able to see this for a few nights after that. So it's not as if it's going to be just that one night. If it happens to be a cloudy night on the 3rd of May, you'll still be able to have a look. Okay. So again, we're very low in the sky, less than 10 degrees, but if you get a good low horizon, you may be able to see it. Of course, there's always an issue looking out across the strait to Vancouver Island. There's often kind of clouds on the horizon, but sometimes you're lucky. So that's May the 3rd at 20 after 9. Notice, of course, that dusk is getting later and later, as it always does at this time of year. Okay, so now this is May the 12th at 9:30, and this is May the 11th is the new moon. Basically, when the moon is as close to the sun as it's going to get, and so this is one day past. So we get a very, very close to a new moon, and we've got Mercury, and we've got Venus and the moon. So again, the reason why the planets are way over on one side of the slide and is so that I can get the west direction on the other side of the slide, so you can get a sort of a sense of the scale of things and where this is. So this might be a time when you might even use Mercury to find the moon, because the moon is going to be just a very dimly lit object at this time of the month. So again, well, Mercury is a little bit higher than it was before, so better chance of seeing it. Now, um, the next day, the moon, of course, will have moved substantially. And so there you've got Mercury and the moon. And so again, it's just the thinnest little sliver. And you'll either find the moon and it'll help you find Mercury, or you'll find Mercury and it'll help you find the moon. And that's, again, it's well above the horizon by now. And so if it's a decent day, a much better chance of seeing Mercury. So that's May the 13th. That's the day before our next Astronomy Club meeting. And then the 14th, the moon just again moves off into sort of Nowheresville. And then I just couldn't resist going to the following day. And this time you get, well, these are just two shots of the same thing, just slightly later. The little dot right next to the moon, right there, that's Mars. And that's probably a good time to see the moon in conjunction with Mars, because it's such a faint crescent moon that it won't sort of drown out the light from Mars. So if you waited just a little bit later in the evening, it'll be even brighter, 9:45 p.m., May the 15th. And again, nice chance to sort of see Mars and the moon side by side. Okay, so if you look at what's happened over the time, those 4 days, basically we have Venus and Mercury and Mars. And so the moon started out right next to Venus, and then it kind of went up to just near Mercury, and then kind of Nowheresville, and then up to Mars. And then actually the following evening, it goes up right beside the Gemini twins. So that raised a couple of issues. First of all, just seeing the Gemini twins there reminded me of something that I learned recently. I don't know if you remember, well, many of you remember Scott Harlow. He gave me a Christmas present a year and a half ago, well, at Christmas 2019. Maunder, Walter Maunder, the guy that did the sunspot studies, he wrote a book, and it was called Astronomy of the Bible. And I thought, well, that's a pretty strange book, because I didn't think there was that much astronomy in the Bible. And he said, and he agreed with me. But what he did say was that the astronomy of the ancient Near East can illuminate some of the things, some of the calendar things that occur in the Bible. So I've been learning a lot about the ancient Near East astronomy. And one of them was this, that the Gemini twins were the signal for the start of the new year in about 4000 BC. If the new moon, that is the earliest time that they could see the moon in the new month, if that was right parallel with the Gemini twins, then that meant that this was the first month of the new year. Typically, they would just count 12 lunar months and then start the next year. But of course, the trouble with that is it slips farther and farther out of line with the seasons. And so then some brilliant person said, hey, we don't just count 12 months. What we have to do is line it up with the Gemini twins, and that'll start spring. Spring will start when the new moon is right parallel with Gemini. So that was 4,000 years ago. And there was a Babylonian inscription that shows the crescent moon and 2 stars beside it. Well, so that indicates that process was being used in 4000 BC. Well, this is Capella. And by 2000 BC, they had to change the start of spring to the new moon parallel to Capella. And this is a phenomena that's known as the precession of the equinoxes. So this is how they sort of regulated their calendar 6,000 years ago, 4,000 years ago, and they had to make that adjustment. So it was just a kind of a curious fact. Of course, nowadays we would have to use some much less impressive nondescript star that's below Capella by quite a bit. Okay, but that was thanks to Scott Harlow's present to me a couple of Christmases ago. Okay, so, but the other thing was seeing this moon kind of going up in the straight line kind of reminded me of the distinction between the motion of the moon through the day or the night and its motion through the month, and the same with the sun. So I decided to sort of do a little bit of a talk on that, and sort of partly for my good and partly for your good. So here we just have the sun as it was, or this will be on May the 13th. And this is the equatorial grid with the equator on it. So this is the grid that astronomers use all the time. And this is sort of your polar aligned grid. So there's an equator, and notice that the equator starts in the east and sweeps over to the west. And you'll also notice that it's 41 degrees, it peaks 41 degrees above the horizon. And that's because we're 41 degrees from the North Pole at latitude 49. That's 41 degrees. So that's the equator. Okay. And then, of course, it just goes higher up, and we'll take a look at the significance of that. So here is the sun, and I've turned, and this is something you can do in Stellarium. You can turn off the atmosphere, and now you can see the stars even when the sun's out, as it is in this picture. And so what we're going to do is we're going to see how the sun moves relative to this equatorial grid, okay? But at the same time, we have this line, this red line, and this red line is the ecliptic. And notice it doesn't line up with the equatorial grid at all. And that's the line that the sun follows, whereas the easy east-west line, that's the equator of the equatorial grid. Incidentally, you'll notice that the Orion sits right on the equator, and the belt of Orion just basically touches the equator. Okay, so how does this work? Well, let's see if I can get this to go here. This is the first time I've done this. So this is how the sun moves throughout the day. So basically, it's pretty much motionless on this ecliptic. And this ecliptic, and all that's happening is just a simple rotation of the sky. You can see there's Orion just stuck on the equator. So it's always going to rise in the east, and it's going to set in the west directly. Meanwhile, this ecliptic is sort of stuck on this ball that we're looking up at, and it's stuck at an angle. And so we're now rotating it around to the far side. It's getting towards, let's see, we're at 2 a.m. in the morning. And notice that it gets right there to about 23.5 degrees below the equator. Oh, that should be a significant number. That's the tilt of the Earth's axis. And then as it come around for the next day, there's the sun, and it's still just tracking along this equatorial grid. So as it rises in the east and it swings across and sets in the west, it's just following the equatorial grid. You'll also notice that the peak of the ecliptic here is, again, 23.5 degrees above the equator. So even, you can sort of use this to kind of position yourself. You position yourself in, or the grid, this line, you can position it just by kind of estimating, 40 degrees up, that's the equator. And then another 23 degrees above that, well, that would be the peak of the ecliptic. And notice it's right above Orion, right above Betelgeuse. That's where and it's always going to be it's always going to be there, at least from year to year. Okay, so now let's move on. Now what we're going to do is we're going to try and watch the yearly motion of the sun. So here we have the sun, and it's actually on April the 9th at 5:15. Just happened to choose that number. this today. So that's where the sun is. And we're going to see how that is oh, there's your ecliptic, there's your equator. And now we're going to watch this thing as it progresses through the year. Okay, okay, here we are. Now okay, here we are. This is now the motion of the sun through the year. Okay, so it's stuck at a particular time of day, and it's going up that ecliptic and down. It's going down right past, you see this little marker here, that's the equinox right there. And now it's heading down to winter. So it looks like at this time of day, which is at 4:18, it actually sinks below the horizon. And then this will be the spring equinox. And so that's what happens to the sun during a year. So the moral of the story here is that you've got this rotating sky, you've got this simple grid. The grid begins in the east, it arcs around to the west, it goes up 41 degrees above the horizon, and then there's other parallel lines, and they just simply rotate, and that's the motion that the sun and the moon follow during the day. But if you look at it during the year, the sun gradually moves up this ecliptic. Notice it's going in the opposite direction from the direction it seems to be going around the Earth. It goes up, peaks at June 21st, and then arcs down through the equator sometime in let's see, in September 21st, and then plunges down. Okay, so that gives you an idea. And then, of course, if we just let the constellations sort of show through, you can see that we've got along the ecliptic, the famous constellations of the zodiac: Taurus, Gemini, Cancer, Leo. Whereas along the equator, the only interesting one here is Orion, and there's a few other little spots, but those are not the famous ones. So it's the constellations that the sun goes through that form the signs of the zodiac. And if we look, this is the winter constellations: Virgo, Libra, Sagittarius, Capricorn, Aquarius. So that's where those come from. So that's basically sort of an effort to kind of show you how the sun moves through the day and how the sun moves through the year. I hope that was useful. So I hope you have a great month. I hope you have a chance to get out and take a look. And I want you to remember that you are socially distanced from the stars. So there's no danger here if you go out and look at them. Okay, so that's it for today.